All right. We need to cover 1.6 to get ready for the things that we'll encounter in Chapter 7. So if you'll just follow along with this worksheet, fill in the blanks. It's a pretty easy section, but you do need to be reminded of and do a little bit of practice with exponents and these types of expressions. That'll make Chapter 7 a little easier. So a couple quick reminders. An exponential expression actually has two parts. One of them is called the base and the other one's called the exponent. Okay, you're probably familiar with that, but it's a good thing to keep in mind whenever we're working with exponents and exponentials. So the base, I've used a B for that, and that number up there, it's smaller and it's written what we call superscript, up above and a little bit smaller. That's the exponent. Okay. And what the exponent does is it tells you how many times you use the base as a factor in a multiplication problem. So exponents are just they're kind of shorthand for writing multiplication problems. So if we look at this exponential expression right here, 2 to the third, the base is 2, the exponent is 3, and what it tells us is that we're going to use the base, 2, 3 times in a multiplication problem. So it's going to be a factor 3 times. And we call this expanded form. So 2 to the third really means 2 times 2 times 2. We use it 3 times again. So if I have 3 to the fifth, I'm going to use 3 5 times. And it's literally that simple if we're just writing an expanded form. But here we've got a variable expression. So I've got 4 squared. So that's going to be 4 times 4. X to the fourth, that means x times x times x times x, and then y to the third, y times y times y. So there's our expanded form. Now, one thing that may not be as familiar is just plain old exponential expressions like this, 2 to the third, 3 to the fifth, stuff like that, are exponents that have negatives in them. Okay? If you have a negative in the exponent, we could kind of break it up into 2 parts. That 3 still means that we're going to use the 2 3 times as a factor, but the negative means this word right here. It means reciprocal. So it doesn't mean that we're going to do 2 times negative 3 or anything like that. Okay? What we do is we do the reciprocal of this expression right here. So if I have 2 to the negative 3, that means 1 over 2 to the third. It means the reciprocal of 2 to the third. So you'll notice that when I move it from the top down to the bottom, it changes the sign of the exponent. So this is what we've got here. So if I write x to the negative 6, that means the reciprocal. That's what that means. So this is going to be 1 over that exact same expression, 1 over x to the 6th. Now, it works this way also. If I have 1 over m to the 4th, I can write that as m to the negative 4. We don't do that very often. We normally like things written with positive exponents. So that's how we do that. But you'll notice a pattern here. When we move it from the top to the bottom, it changes the sign of the exponent. And when we move it from the bottom to the top, it changes the sign of the exponent. So we could actually write 3 squared with a negative exponent. We could do it this way. Now, just to double check and make sure, you know what 3 squared is. 3 squared is 9, so I'm going to put a 9 over here. But let's see what this means. We've got a 1 over. This is 3 to the negative 2. Well, negative means reciprocal, so if I wanted to write it this way, that would be okay. And you'll remember from the last chapter how to work with complex fractions. This is 1 divided by 1/9. We're never going to divide by that 1/9. I'm going to flip that over and I'm going to multiply by its reciprocal. So that's going to be 9 over 1. So I have an answer of 9, just like we did right there. So those two are the same thing. 3 squared is the same as 1 over 3 to the negative 2. And again, you want to note, if I move it from the numerator to the denominator, it changes the sign of the exponent. Okay? So we've written these with negative exponents. We've written these with positive exponents. Now we generally write things with positive exponents. So here's what we're going to do. We're going to look at each factor in this little division problem, and we're going to look at it and decide, is it okay? Are we fine with the way it's written, or do we need to change that? So the 3 is just fine. So is the 4. The y to the 4th is okay because it has a positive exponent. But x to the negative 2, we don't usually write negative exponents, so we're going to do this. The 3 is fine. The y to the 4th is fine. The 4 is fine. I don't like that x to the negative 2, so I'm going to change the sign of the exponent by moving it in the denominator. So that's going to be x squared down there. I don't like the sign of that exponent right there, the z to the negative 3, so I'm going to move it on the top. And that's going to be, z to the third when it moves on the top. Again, we can change the sign of the exponent by moving that exponential expression from the top to the bottom or the bottom to the top. If you wanted to clean that up just a little bit, I suppose we could do that. Probably should have planned ahead. And there we go. Okay? All right. I do want to point out a couple things that people typically make mistakes with. So let's take a look at this one here. Negative 3 squared. So if somebody just said, hey, what's negative 3 squared? Most people would say that the answer to that is 9, but it's not. Negative 3 squared, the answer to that one is 9. And here's the difference between the way these are written. An exponent applies only to what it's over. So this 2 only applies to the 3. If we want it to be applied to the negative, we need to put that in parentheses. So this literally means negative 3 times a negative 3. We use the base twice as a factor. So negative times a negative is a positive. Here, this means negative, and we only use the 3 twice. So the answer to this problem is negative 9. So we have a negative 9 here and a positive 9 here. So that's important to keep in mind here because there are a couple exponents in this problem. We've got a set of parentheses. This is negative 4 times negative 5x to the negative 3, y to the 9th, that quantity squared. This 2 applies only to these guys in parentheses. So we've got a negative 4. I have a negative 5 and it's squared. I have an x to the negative 3 and it's squared. And I have a y to the 9th and it's squared. Now, we'll review this a little bit more later on, but so the numbers are pretty easy. So this is negative 4, negative 5 squared, negative times negative is positive, that's going to be 25. If I have a power raised to a power, I multiply those exponents. So that's going to be negative 6, power raised to a power, I multiply those, that's going to be y to the 9th. Okay, because that literally means y to the 9th times y to the 9th. So I've got 18 of them all. 18 of them all together. Power to a power, 2 times 9 is 18. There we go. So this is what I've got. I've got negative 100, x to the negative 6, y to the 18th. Now take a good look at that. Do we like the way that's written? The negative 100 is okay. We can't really do anything about that. The y to the 18th is okay. But what we don't like is we don't like that negative exponent. So I'm going to keep this, move that down in the denominator, and that will change the sign of the exponent. So we get negative 100, y to the 18th on the top, and then x to the 6th on the bottom. And then there's a couple simple facts that you just have to remember, but they do tend to be easy to forget. If I have a huge number, or any number for that fact, raised to the first power, we just use it once. So it's that exact same number. It's whatever the base was. So any number to the first is just that same number. So a to the first, just a. This huge number raised to the 0. Any number raised to the 0 power is 1. All right? And so any number, that's what we've represented here. Any number, just have a variable there, raised to the 0 power, that's going to be 1. All right? Now that brings us to this, the last thing on this page, all of these different properties of exponential expressions. So if you have 1 as an exponent, that's great news because it's just whatever the base is. Any number raised to the first power is just that same number. 0 as an exponent. Any number to the 0 power is always 1. Remember, that's 1. And then if you've got a negative exponent, remember that negative means reciprocal, so this would be 1 over a to the n. Okay, this is called the product property of exponents. If you're multiplying these together, you actually add the bases. So this would be a to the m plus n. An example of something like that would be x squared times x to the third. That's going to be x to the fifth. Okay? If when we're multiplying them, we add the exponents, what do you suppose we do when we're dividing? We're going to subtract. Subtract the bottom one from the top one. Okay? And you can see one reason for that would be this. If I move that into the numerator, then I'd add those together. So that would be a to the m plus negative n. That would be a to the m minus n. So you can reason your way to it that way. Power raised to a power, we multiply those exponents, so that would be a to the m times n. And let me give you a numeric example here. If I have x squared cubed, x squared times x cubed is x to the fifth. This is going to be x to the sixth. It literally means x squared times x squared times x squared. Remember, you use it 3 times, so we'd have 6 x's altogether. The exponent here applies to each part of the product, so this is a product raised to a power, so that would be a to the n and b to the n. We've kind of already used that up there earlier. And then a quotient raised to a power, this is nice, we can just apply the exponent to the top and bottom separately. Okay, kind of like distributing. Okay, let's flip that page over. Now this page it's got quite a few problems on here. What I'd like you to do is I'd like you to run through right now and see if you can do these problems without any help. And then, so if you want to pause the video right now, run through and do 4, 5, 6 of them, see how you do, and then look at the answers. If you're not getting them right, you probably ought to watch the video again or watch how I do all of these. So here we go. You'll notice the base is the same. So again, if you haven't done these yet, pause the video, do several of them, and then start it back up. So this is 3 to the 8th times 3 to the 9th. So that has 8 3's multiplied together here, 9 3's multiplied together here, and then we're multiplying them all together. So that's going to be 3 to the 17th. Remember, when you're multiplying them and they have the same base, you add the exponents. So there we are there. Let's take care of the numbers. That's going to be 6. I have 5 a's here and 4 of them there. Again, we're multiplying them together, so we add the exponents. So that's a to the 9th. Let's see, nothing weird going on here, so let's just multiply the numbers. Negative 24, 7 m's here and 2 of them there, so that's going to give me 9 altogether, because again I add the exponents there. When I'm dividing, I subtract the bottom one from the top, so that's going to give me a to the 11 minus 8, so that's going to be a to the third. What I like to do with these is I like to say, look, there are 11 on the top and 8 on the bottom. I'm going to cancel these 8 with 8 of those, and that'll leave 3 there. Okay, I just find that a little bit easier than doing the subtraction, and I think it makes more sense. Let's look at this problem right here. We'll take care of the numbers. Negative divided by negative is positive. So that's going to be a 5 left on the top once we cancel the 20 and the 4. So we've taken care of those. These 2 will cancel 2 of those. There'll be 6 left, and they're on the top. These 2 will cancel 2 of those. There'll be 3 left, and they'll be on the top, so that'd be y to the third. And this one will cancel 1 of those, so there'd be 2 left. So there's our answer there. And then, okay, this is a good problem. It's similar to the one that we did earlier. Remember, the entire base is negative 3. That negative right there means reciprocal. Don't forget that. The negative in the exponent means reciprocal. So let's do this first. 1 over negative 3 squared. We've taken care of the negative part of the exponent. Now let's do the rest. The 2 applies to both the negative and the 3, so there are 2 negatives and 2 3's, so that's going to be negative 3 times negative 3. That's a positive. So positive 1/9. This one's a little bit different. You'll notice it's not in parentheses, so we could do it this way. We could write it as negative 2 to the negative 4. That's going to be a negative 1 left on the top. When we move this on the bottom, it's 2 to the 4th, so that's a negative on the top and a 16 on the bottom. And again, what we don't like about this problem right here is it's got a negative in the exponent. Let's move that to the top, so that's going to be 10 to the third. 10 to the third is 1,000 if we simplified that completely. Again, if you wanted an alternate way to do this problem, it's that. And we never divide by a fraction. We'll always flip that over and multiply, so that'd be times 10 to the third. There's our 10 to the third, and we still get 1,000. Okay. This one's kind of interesting. We don't like the negative 6 in the exponent on the top, so we're going to take that and move it on the bottom. The 7's fine. The s squared is fine. And when I move it to the bottom, I get a t to the 6th. But is that it? Remember, if we move this down, if we're ever working with a division problem, there's always a 1 left. Okay, so you definitely want to put that in there. And now a little bit more complicated problem. We're going to multiply these together. So this is going to be negative 18. Numbers, the coefficient there is pretty easy. X to the 6th times x squared. That's going to be x to the 8th. We've got 8 of them all together. Now there are 2 ways to handle this right here. I have negative 2 of them if you want to think of it this way, and positive 3 of them, so that's going to give me a y. Or we could do it this way, negative 18, x to the 8th. We could leave the y to the 3rd on the top and move the y squared on the bottom and then cancel. Either way, you get that answer right there. Okay? Next one, number is 10, so our coefficient is 10. Well, this would be negative 2 of them and negative 4. That's negative 6 of them altogether, but we like that positive, so I'm going to write it on the top. Negative b to the, b to the negative 3rd, and then this is an exponent of 1, remember. So that would be negative 2 of them altogether, so that would be on the bottom. So there's our answer there. Now, if you need to do it this way, go right ahead. And then we're going to write it with positive exponents, a to the 6th b squared. Same answer either way. And then this one. Okay, what I like to do with these is I'll do a little bit of simplification, but not too much. Maybe get rid of the numbers, 4 left on the bottom. I like to write it with all positive exponents. So I've got a to the 6th, c to the 8th. I'm going to move that b to the 4th down there. So I've taken care of all those guys here. I'm going to move the a to the 4th on the top. B to the 5th is fine, and c to the 9th is okay. Now I start simplifying. I've got a to the 10th on the top. I've got a 4 and a b to the 9th on the bottom. Now let's take care of the c's. 8 on the top, 9 on the bottom. That means these 8 will cancel with 8 of those, and there's 1 left, and it's on the bottom. All right. Okay, this is kind of an interesting problem. This exponent applies to that entire thing in parentheses. And what does that mean right there? What does the negative mean? It means reciprocal. So we're going to take this fraction and we're going to flip it over. So we're going to do 5x to the negative 1, y to the 4th, negative 4, x to the 4th, y to the negative 2, and that's raised to the 4th. So this is going to be 5 to the 4th, x to the negative 4, y to the 16th, negative 4, I'll put that in parentheses because the negative's in there also, to the 4th, x to the, this is going to be 16th, and this is going to be y to the negative 8. And then I can just move things around. 5 to the 4th is 625. I like the y to the 16th. I'm going to move the other one on the top. 4 to the 4th is 256, and it is positive because we've got a negative times a negative times a negative. 4 negatives make a positive. And then I have x to the 16th and x to the 4th when I move that one down on the bottom. So 625, y to the 24th, over 256, x to the 20th, and there we go. Can't cancel anything, that's for sure. Okay, now that's one way to do it, but that may not be the easiest way to do it. So here's another thing that you could do. We could just apply the exponent to everything in parentheses. Negative 4 to the negative 4th. X to the 4th to the negative 4th would be the negative 16th. That'd be the positive 8th. Oops, let me erase that. Negative times a negative there. On the bottom we have 5 to the negative 4. Negative times a negative would be a positive. And this would be y to the negative 16th. And then just start moving things around. We'll move any with negative exponents to either top or bottom, wherever they are. So this gives me negative 4 to the 4th and 5 to the 4th. I like that x to the 4th there, but I'm going to move that x to the negative 16th on the bottom. I'm going to move that to the top, and this. And if you take a look here, we're about right there. So we can just finish it off there. Okay, last problem. Explain why negative 1 to the n equals 1, negative 1 to the n equals positive 1 for any even number n. So if you think about that for just a second, let's plug in a number. Let's plug in an even number. So this is called coming up with a numeric example. Let's check and make sure it works if it's a 2. Negative 1 times negative 1 is positive 1. Well, let's try another one. Most convenient one would be a 4. So that's going to be 4 of these, right? 4 negatives makes a positive, and 4 ones, still a 1. Okay, so explain why negative 1 to the n equals positive 1 for any even number n. And it would be because you have an even number of negatives. Okay, all right, good luck on the assignment. Make sure you have that done before Monday so we can get right into Chapter 7.